Welcome to this presentation. In this video, we'll be looking at wireless networks EC6802 for final year ECE students. Unit 1 deals with wireless LAN, which covers wireless LAN technologies, HyperLAN, Bluetooth, and WiMAX. Wireless networks are computer networks that use radio frequency channels as their physical medium for communication. It utilizes specific equipment such as network interface card, access point, and routers in place of wires for connectivity. And in wireless network architecture, n number of computers is connected to router through wireless links. And the various types of wireless networks are W1, WMAN, WLAN, and WPAN. In W1, that is wireless wide area networks, connections can be made over large geographical areas across cities or even countries. For example, you can say cellular networks and satellite networks. Whereas WPAN, that is wireless personal area networks, this WPAN enable users to establish wireless communication among personal wireless devices such as PDAs, cellular phones, and laptops that are used within a personal operating space that is typically up to a 10-meter range. For example, you can say Bluetooth and infrared. In wireless LAN, this wireless local area network, it enables users to establish wireless connections within a local area that is within a 100-meter range. For example, you can say Wi-Fi and HyperLAN 2 comes under this category, wireless LAN. And wireless MAN, that is wireless metropolitan area networks, it enables users to establish broadband wireless connections among multiple locations. That is for example, you can say among multiple office buildings in a city or on a university campus. And wireless networks consist of two different basic system architectures such as infrastructure and Adhoc network, infrastructure based network and Adhoc network. First, let us see the infrastructure based wireless networks. And infrastructure networks contain special nodes called access points which are connected via existing networks. Here you can see the components of infrastructure and a wireless port are specified for IEEE 802.11. Several nodes they are called as stations or connected to access point here, and the stations or terminals with access mechanism to the wireless medium and radio contact to the AP. AP means access point, okay. And the stations and the AP which are within the same radio coverage, they form a basic service set, that is BSS, and a distribution system connects several BSS via the IP to form a single network and thereby extends the wireless coverage area. And this network is called extended service set, and the portal denotes that the bridge to other networks. Okay, and the next type of network that we see here is the Adhoc network. So in addition to infrastructure based network, the IEEE 802.11 allows the building of Adhoc networks between stations, and thus it forms one or more independent BSS as you can see in this diagram. In this case, an IBSS comprises a group of stations using the same radio frequency, and for example, stations 1, 2, 3 are in, suppose if stations 1, 2, 3 are in IBSS 1 and station 4 and 5 in IBSS 2. For example, if that STA 3 can communicate directly with STA 2 but not with STA 5. So IEEE 802.11 and HyperLAN 2 are the examples of infrastructure based networks, whereas the Bluetooth is a typical example for Adhoc network. Now we can see the various WLAN technologies. WLANs are flexible data communication system, and they are implemented as an extension or an alternative for wired LANs. So using radio frequency technology, WLANs transmit and receive data over the air, minimizing the need for wired communication. And thus the WLANs combine data connectivity with user mobility. They are very simple to install. And the technologies available for use in WLAN include infrared, UHF, and spread spectrum. Now let us see the first case, infrared technology. Infrared is an invisible band of radiation which exists at the lower end of the visible electromagnetic spectrum. And this type of transmission is most effective when a clear line of sight exists between transmitter and the receiver. And two types of infrared WLAN solutions are available, that is diffused beam and direct beam. When used in indoors, it can be limited by solid subjects such as doors, walls, or racking. In addition, the lighting environment can affect the signal quality. For example, loss of communication may occur because of the large amount of sunlight or background light in an environment. The fluorescent lights also may contain large amount of infrared, and this problem may be solved by using high signal power and an optional bandwidth filter, which reduces the infrared signals coming from outside source. And in the outdoor environment, snow, ice, or fog may affect the operation of infrared-based system. And the next category is UHF narrowband technology. And the UHF wireless data communication system have been available since 1980s, since 1980s. And these systems normally transmit in the range of 430 to 470 megahertz frequency, with rare systems using the segments of 800 megahertz frequency range. And the term narrowband is used to describe this technology because the RF signal is sent in a very narrow bandwidth, typically 12.5 kilohertz to 12.5 kilohertz or 25 kilohertz. Many modern UHF systems are synthesized radio technology, and this refers to the way channel frequencies are generated in the radio. Synthesized radio technologies uses a single and standard crystal frequency and derives the required channel frequency by dividing the crystal frequency down to a small value and then multiplying it with the desired channel frequency. And synthesized UHF based solutions provide the ability to install equipment without the complexity of hardware crystals. And additionally, the synthesized UHF radios do not exhibit the frequency drift problem experienced in crystal controlled UHF radios. And the next technology is spread spectrum technology. Most WLANs use spread spectrum technology, wideband RF technique that uses the entire allotted spectrum in a shared fashion. That is, the spread spectrum system spreads the transmission power over the entire usable spectrum. And this is obviously less efficient use of bandwidth than the narrowband approach. However, the spread spectrum is designed to trade off bandwidth efficiency for reliability, integrity, and security. So, by operating the systems across broad range of radio frequencies, the spread spectrum device could communicate clearly despite the interference from other devices using the same spectrum in the physical location. Actually, two modulation schemes are commonly used to encode the spread spectrum signals. One is DSSS and FHSS. DSSS means direct sequence spread spectrum and frequency hopping spread spectrum. Now, let us see the IEEE 802.11. IEEE 802.11 specifies the most famous family of WLANs in which many products are available. As the standard number indicates, this standard belongs to the group of 802.XLAN standards. For example, the 802.3 Ethernet or 802.5 token ring. This enables the users to establish wireless communication within local area, that is within 100-meter range. The objective of IEEE 802.11 standard was to define a medium access control sublayer and MAC management protocol and services, and 3 PHI, that is physical layers for wireless connectivity of fixed, portable and moving devices within a local area. This IEEE 802.11, we are going to see about system architecture, protocol architecture, physical layer, MAC layer, and 802.11b and 802.11a. Thank you.